I'm going to give the floor first of all to Nick Tyler, the Director of the Centre for Research into Accessibility in the United Kingdom. And I would like to say that he also is on the publishing board of a journal about research into Design for All in different areas at an international level. So I'm not going to go into greater detail. I'm not going to say more about Nick because I could talk for a long time. I think the best thing would be to give him the floor. Good morning to everyone. Good afternoon to everyone. I'm Nick Tyler. I'm a professor at the London University, and I have a research group dealing with accessibility. And our idea is to bring science to the subject of accessibility. We want to understand how and why we have problems in designing a city or a vehicle or a home for all. And in order to obtain this knowledge, we have to design better in the future. Then I discovered 10 years ago, I guess, more or less, that in order to do this kind of job or to work in this area, it's necessary to use a lab. So we developed an accessibility lab. It's called PAMELA, Pedestrian Accessibility and Movement Environment Laboratory. Pamela is a woman's name in England, and I have many problems with my wife when I go and meet Pamela. The idea of Pamela is an area, it's a pedestrian area, but we can control all of the aspects of this area, of this space, the kind of surface, its topography, the light, the noise within this laboratory. So we can study how people interact, taking into account the sensorial abilities and the environment itself. Above all, the pedestrian environment. Why do we control so many variables in this pedestrian area? Well, we can study how exactly people interact. So within my group, I have psychologists, I have people who are studying ethics, engineers, designers, neurological experts. Many different areas are covered. And so we've been able to develop an understanding which is quite complete. It's a complete understanding of all of these interactions. For example, we can study how the brain interacts with the environment in a direct way. Most of our pedestrian interaction is done unconsciously or in our subconscious. And we want to understand how the brain moves our legs in order to move in this setting. And in order to do this, we have to study, for example, our eyes. We have teams that study eyes during the process of moving. And for this reason, we are able to look at and study how to design things. And I have some examples to show you. Let's have a go. Success. Obviously, women are more intelligent, always the case. Here we have a photo of an experiment that we did on the London Underground. The people, any of you who know London Underground, you'll know the phrase mind the gap. Mind the gap is a very famous phrase because we have lots of gaps in the London Underground system between the platforms and the trains. The system is very old, and the design wasn't thinking about people with movement difficulties. So London Underground is interested in improving this situation without having to rebuild the whole system, the whole structure. So they're looking at how to reduce these horizontal and vertical differences. But there are problems in looking at the acceptable possible gap or height differences. And in our lab, we've been studying this, and you can see on the photo here an example in which we are testing out different ramps, different inclinations of ramps, to see if there are problems for blind people or people in wheelchairs, etc. Here we are testing the setting for blind people, for the visually impaired, to see if they have any problem in locating where the slope starts, where the ramp starts, but also for dogs, because dogs know that it's a lab. They know it's not a real station, so they have no interest in the experiment. And for the people, it's easy to convince them, to make them believe that they're in a station with noises, etc. But the dogs are much more intelligent. This kind of experiment is important because we are developing the specifications for the London Underground ramps. During the same experiment, we tested the horizontal gaps, and you can see in this photo that we have people on wheelchairs, and we're testing this horizontal gap of different sizes to see which are possible and which are impossible. Here we have vertical differences, vertical height differences. So we've got two things here. First of all, which ones are the possible and impossible vertical differences, so height differences, and also if there is a slope on the platform, what would happen if the door of the train, if it's open, inclined area. And we have to test this in order to deal with safety issues in the system. Another kind of experiment is about buses. We're working on this at the moment. We're working on the problems that exist for people inside a moving bus. This is a problem for people, for elderly people particularly. And we're trying to understand how we can design an operating system or method in order to limit these problems. We can change noises. For example, we can have trains, planes, or in the street, or anything inside our lab, so we can create a realistic environment, but also we can test out noise problems for people moving around this pedestrian area. So it's a lab which is available to people who want to carry out experiments. We do experiments for people from Europe, Canada, Japan, China, because it's more or less the only lab in the world with all of these different variables and control over the environment. So I wanted to describe a little bit, just for a few minutes, this lab in order to give you an idea of the kind of work that we're doing. And that's what I wanted to do here today. Thank you.
Muchísimas gracias, Nick.
Thank you, Nick. That was really very interesting.